Where does the two different oceans meet? Learn the mystery and specialty about the Atlantic and the Indian Ocean, and where these two oceans collide. The Indian Ocean and the Atlantic Ocean meet in only one place. That meeting is not without drama. Our planet is a complex web of natural wonders, and among them are the fascinating oceanic intersections. Like highways of the sea, these intersections are places where two or more oceans meet. The Atlantic and the Indian Ocean meet. From east of Africa is the Indian Ocean, to the west the Atlantic Ocean. Together these two vast bodies of water cover around 50% of the surface of our planet. They meet in one place only, a bit south of the coast of South Africa. Two such oceans are the Atlantic and Indian Ocean, each with their distinct characteristics. The Atlantic, known for its vastness, and the Indian for its warmth, are not just bodies of water but lifelines that shape our world's climate, support diverse marine life, and serve as vital navigation routes. These intersections become arenas of unique marine phenomena, from differences in water density to variations in color. Such intriguing combinations give rise to an array of questions. As we set sail for this intriguing intersection, brace yourselves for a voyage of discovery. In the South Atlantic, between South America and Africa, there is a huge eddy. The water flows westward south of the equator, then south along South America, and eastward towards Africa. When the current meets the African coast, cold water is forced up from the depths. A bit off the coast, furthest south in Africa, this cold water meets the warm Agulhas current, with water 5 degrees warmer. The clash between cold and warm water is dramatic. Huge eddies are formed, both on the surface and down in the depths. In the eddies, 20 to 25% of the warm and salty water from the Indian Ocean mixes with the cold Atlantic water, and flows northward along the west coast of Africa. This current is called the Benguela, and some of this water eventually ends up in the Gulf Stream. What is left of the Agulhas current loses out to the cold Atlantic current, and the wind that constantly blows from the west, and is forced back towards the east. Some of this water flows northward and back into the Indian Ocean, some becomes part of the ocean current that circulates around Antarctica. In a word, yes, the Pacific Ocean and the Atlantic Ocean mix. However, it is not as simple as two bodies of water simply blending together. The two oceans have different densities, temperatures, and salinities, which means that their waters do not mix easily. This is especially true in the upper layers of the ocean, where the differences in density are greatest. At the surface, the Pacific Ocean is generally warmer and less salty than the Atlantic Ocean. This is because the Pacific Ocean receives more sunlight and has a lower rate of evaporation than the Atlantic Ocean. The difference in temperature and salinity between the two oceans creates a barrier that prevents their waters from mixing easily. However, there are some areas where the Pacific Ocean and the Atlantic Ocean do mix. One such area is the Drake Passage, which is the narrow strait that separates Antarctica from South America. The strong currents in the Drake Passage mix the waters of the Pacific Ocean and the Atlantic Ocean, creating a body of water known as the circumpolar current. Another area where the Pacific Ocean and the Atlantic Ocean mix is in the Gulf of Mexico. The Mississippi River carries a large amount of sediment and fresh water into the Gulf of Mexico. This fresh water is less dense than the salty water of the Gulf of Mexico, so it floats on top of it. The two layers of water do not mix easily, which is why the Gulf of Mexico has a distinctive brown color. When strong ocean currents meet like this, upwelling brings nutrient-rich deep ocean water to the surface. Up there in the sunlight, there are good conditions for phytoplankton, which in turn become food for zooplankton, fish, and other animals. In the natal pulses, which are huge eddies of salt and warm water, there is little nutrients and less wildlife. But where these eddies hit shallower water, they also cause agitation and upwelling. The eddies are so large that the heat they transfer to the air above affects the wind pattern, cloud formation, and precipitation in the southern Indian Ocean. The scientists on board are also looking into the effect of this in a warming world. It has been shown that the Agulhas current has changed due to climate change, and that these changes in dynamics, speed, etc., has had an impact on the biology. Understanding this process is important. First, let's get acquainted with the renowned Atlantic Ocean. Covering approximately 20% of Earth's surface, the Atlantic is the world's second largest ocean, boasting an average depth of about 12,000 feet, almost as tall as Empire State Building. This vast body of water is teeming with life, hosting a staggering array of marine biodiversity. Its waters are home to countless species, from the tiniest plankton to the largest whales. But the Atlantic is more than just a marine habitat. It plays a pivotal role in shaping our planet's climate. The ocean's currents act like a giant conveyor belt, redistributing heat around the globe and influencing weather patterns far and wide. Historically, the Atlantic Ocean has been a crucial maritime route, enabling exploration, trade, and cultural exchange across continents. It has witnessed the rise and fall of empires, the discovery of new lands, and the forging of countless human connections. Now, having explored the Atlantic's expanse, it's time to take a dip into the Indian Ocean's depths and its mysteries. Next up, we plunge into the warm waters of the Indian Ocean. This isn't just any ordinary body of water. It's the third largest ocean, stretching over a remarkable 27 million square miles. But what's even more astonishing is its depth. The Indian Ocean reaches down nearly 24,000 feet at its deepest point. This vast ocean plays an essential role in our planet's weather patterns, particularly the monsoons that bring life-giving rains to the surrounding lands. Its warmth fuels these weather systems, creating a delicate balance between land and sea. And let's not forget about its rich marine life. From the smallest plankton to the largest blue whale, the Indian Ocean is teeming with biodiversity. This was also the stage for historical spice trade routes, making it a key player in global commerce for centuries. With the Indian Ocean's warmth still lingering, we're now ready to explore where these two oceanic titans meet. Now we reach the climax of our journey, the intersection of the Atlantic and Indian Oceans. This intriguing point of convergence takes place off the southernmost tip of Africa, near the Cape of Good Hope, a place steeped in maritime lore. But let's clear up a common misconception. There isn't a distinct line in the water where these two vast bodies meet. No, the reality is far more intriguing and complex than that. You see, oceans don't behave like colors in a painter's palette. They don't just blend into each other at a clear-cut boundary. Instead, it's a gradual process, a dance of sorts, where the waters from each ocean intermingle and intertwine over a vast stretch, creating a unique maritime mosaic. This transition zone is marked by differences in temperature and salinity. The warm, salty waters of the Indian Ocean meet the colder, less salty waters of the Atlantic, creating an intricate pattern of water layers with varying densities. This is not something you can easily see, but it's there beneath the surface, shaping the life and currents of these oceans. Speaking of currents, let's talk about the Agulhas Current. This powerful warm current originates in the Indian Ocean and sweeps down the east coast of Africa. As it reaches the southernmost tip, it makes a sharp turn back into the Indian Ocean. Now, here's the interesting part. Some of the Agulhas Current carrying warm, salty water leaks into the Atlantic Ocean, playing a crucial role in the global oceanic circulation system. So, you see, the meeting point of the Atlantic and Indian Oceans is not a line, but a swirling, ever-changing dance floor where waters from two different worlds come together, each influencing the other in profound ways. It's a place where myths are debunked and the intricate beauty of our planet's natural systems is revealed. So, the reality is more complex and fascinating than a simple line on a map, isn't it fascinating?